Oh well, I'm sorry for the second video. There was some interruption. This is the continuation part of stationary point. If you have been following, we left it at a point where I was discussing the squared y over the x squared equals to 0. That is point of inflection. Whereby my last statement that I said there was the y squared. I mean this squared y over the x squared equal means second derivative method. Due to insufficient memory, my PC went off, so I'm sorry guys. So let's follow on the continuation part of that. Now, what I was to do in that part, now I'm doing it here. So just to continue, only examples will be useful for these questions, for whatever we've learned in this part, which is in the second video. Only example will be useful under this question. Now, here we have two ways. We have two ways in which positive, negative, and zero. Remember when I said positive, negative, and zero, what I mean is minimum, maximum, and inflection. So there are only two ways in which positive, negative, zero can be deduced, can be named, or can be tested. Now, number one, we have direct or express. Direct or express. Number two, we have substitution. You must substitute. Substitution. Great. Now, let me start with direct. Direct or express. Now, it is direct or express of what? You just know. Just be patient with me. When it comes to direct or express, in second derivative method, this squared y over the x squared is a number. What I mean by direct or express, when it comes to the second derivative, which is the squared y over the x squared, is a number, right? This squared y over dx squared y is a number which is either positive, negative, or zero. And the positive, negative, zero can also be termed as maximum, minimum, or point of inflection. Great. Let's take this example. Identify the stationary point on the curve. And the curve we have is a y equals to x squared plus 2x plus 3. Identify the stationary points on the curve y equals to x squared plus 2x plus 3 and state their nature. That is the relevant terms of a good questions when it comes to calculus. You will always encounter full at its required length. Testing both way, nature and the points, the stationary points. Let us first differentiate. Now, we have dy over dx equals to what? Equals to 2x plus 2. I think up to this point, you don't have a problem when it comes to differentiating. Okay. And remember, I told you that when it comes to stationary point, you must have an idea in your mind that dy over dx when it comes to stationary point is equal to 0. So that means after differentiating this function or this curve, we should equate it to 0, because that is what the topic stationary point itself speaks or wants a student to know. So already we've done this. That is differentiation. So we are having 2x plus 2 equals to 0. 2x plus 2 equals to 0. There's some things I talked with you in the previous video, which is a connector to this. Be a student who is smart for you to pass mathematics always. Okay. Let me not appear to be talking too much. Now, here we are having 2x plus, 2x equals to what here? Remember one thing, this one is not a quadratic. This one is not a quadratic. So solving it in quadratic way will be useless. So make sure you know the type of quadratic. But now here we have a 2x plus 2 equal to 0. This is just a normal equation. So 2x equals to negative 2. That means our x equals to what? Negative 1. Now, if my x is negative 1, what will be my y? And how will I know the value of my y? I go back to the function or to the curve. You see the order of this y equal to whatever x squared plus 2x plus 3 is called a function. So how do I get my y? I just substitute. Remember what I'm doing? I am getting the point. I am getting the stationary point. That is why you are seeing me getting value x and now trying to obtain value y. I'm trying to get the stationary points, the points of the stationary curve. So how will I get my y? Just substitute. Remember to always have your calculator with you. Upon substituting, remember our x is negative 1. So we shall have negative 1 into bracket squared plus 2 into negative 1 plus 3. So our y will be 2 upon substituting. So that means the stationary point of the function, remember this function is somehow a curve. It is a curve. What do I mean by a curve? This is our Cartesian plane. Then so this diagram has been simplified into some wordings or some mathematical terms, and it is now the one called a function. Remember, this is y equal to what? What was it? X squared plus 2x plus 3. It is a function. It is a curve. So what I'm trying to get is the point under x and under y. That is what I'm trying to get. The stationary point. Remember, this thing is not moving. This thing is constant. I know calculus, and that is why I'm taking some of my time to explain this. And do not judge my English kindly. Great. So what are the point? Negative 1, 2. Tick. Then you continue. Already, you've answered the first part of the question. Remember the question read, identify the stationary point on the curve y equal to x squared plus 2x plus 3. And already you've answered that question by getting the stationary points as -1, 2. Now answer the second part. State the nature. The nature. The nature. Like, remember whatever I've drawn the previous, I've drawn something like this. This one is just a sketch. I don't know how the curve appears. And by determining the nature, I can be able to sketch a good curve the way it appears in reality. So I want to know the nature. How is the curve appearing when it is drawn? So that is what I'm trying to get. Okay, let me wrap this. You'll reach a point, or we shall reach a point, where you will be required to sketch that curve how it has appeared. And that is why I'm telling you first to have an idea of whatever I'm giving at this point or at this juncture. So remember, to get the nature, we must go for the second derivative method. And remember, what are we differentiating? We are differentiating what had been first differentiated. And at our first differentiation, we differentiated what? We differentiated x squared plus 2x plus 3 and got 2x plus 2. So that means 2x plus 2 is what we shall do, or we shall differentiate the second times. Okay, now having the squared y over the x squared, we shall have what? We shall have 2. Only 2. So this is a direct expression or a direct derivative method. And check out that answer. What answer are we getting? What answer are we getting? We are getting 2. And 2 is it positive, negative? 2 is positive. So that means this one is a maxima. So that means that -1, 2 is sorry. I'm sorry. This is positive. So it is minimum, not maximum. Remember, negative goes together in hand with maximum, positive, minimum, 0, point of inflection. So I'm sorry for that. So yeah, we have minimum. Now that means -1, 2 is a minimum point, or is a point of minimum, whatever the English you choose. But so long as you have the minimum, you will be marked correct. You'll be marked right. So that is that. -1, 2 is a point of minimum, or is a point of minimum, or is a minimum point. I think English matters a lot. Is a minimum point. Let me write it that way. -1, 2 is a minimum point. But whatever the English you've just used to use, it will you'll be marked right so long as you have the minimum. Now let us now check at number 2. So that is whatever I've given you here. This one, the d squared y over the x squared is equal to 2. and getting our direct answer, our direct value to be just a number, like it is just two, it is just a number, just a natural number. This is a kind of direct second derivative method, giving you a direct answer to whatever you required. Now, let us check at the substitution. Substitution or presence. Yeah, very much correct. Or presence of variable x, or presence of variable x. Remember, when we've in the second derivative part, there is no presence of variable x. We've just differentiated it and just gotten a natural number direct that way. Now, let us check on this. Here, our dy squared over the x squared, dy squared over the x is a term with a coefficient x. Is a term with a coefficient x. Whatever I'm trying to say is that after differentiating that second derivative, you'll get an answer having variable x. Let's take an example. Identify the stationary point. Identify the stationary point and state the nature of the following function. And what function is it? Y is equal to 3x squared minus x cubed. 3x squared minus x cubed. Remember, at the back of your mind, this one is a stationary. You are dealing with the stationary point. And do not forget the powerful term that dy over the x equals to 0 when it comes to stationary point. So dy over the x equals to 0. Now differentiate this. What shall we have? We shall have 6x minus 3x squared. 6x minus 3x squared. So we have 6x minus 3x squared equals to 0. Now remember now, this is where I want you to be a good student. This is a part where I want you to be someone highly thinking. This is a quadratic, and there's a way different types of students will tackle this question and come with the different answers. Some will be wrong, obviously, some will be right. Now, a good number will do it this way, and by following this way, they're out of the competition. Then they will be wrong. They will not get the, if it was section B, they may miss a lot of marks. Being that you are taught, you are learned, you will factorize what is common between 6x in the expression 6x minus 3x squared. Obviously 3 is common and x is also common. So we have 3x into what? 2 minus what? Minus x equals to 0. Now we are having 3x equals to 0 or 2 minus x equals to 0. Solving this part, Roman 1, this part, Roman 2. Solving this part, obviously our x will be 0. Solving this Roman 2, our x will be 2. Very much easy. Now, when x is 0, what is y? When x is 2, what is y? You come here when x is 0, comma, what is y? And when x is 2, what is y? Give that work to your calculator. Make sure your calculator does everything for you when it comes to that part. You don't have to verify your work. Now, let's having zero, when you substitute it to this point, obviously you'll get y to be 0. Substituting x equals to 2 in this function, remember you must refer back to the function for you to get y, because that is the only place where y answer lies at. So what will be my y? After substituting back, y will be 4. So in this type of question, we have two points. So we have the first point 0, 0, and what? And 2, 4, and 2, 4. So this is our answer. Tick. Tick. You've answered the first part of the question. Now, you want to now answer the second part. That is determining their nature. Determining their nature. To determine the nature, you use the derivative method. D squared y over the x squared equals to 0. So what are we differentiating the second time? It is what we had first differentiated. So after differentiating 3x squared minus x cubed, what did we get? We got 6x minus 3x squared. So 6x minus 3x squared is what we shall differentiate the second time. So differentiating this, d squared y over the x squared will be what? Will be 6 minus what? Minus 6x. Now, this is what I refer to as the substitution. This is what I refer to as the substitution part, because for you to get, or for you to determine whether the numbers are positive, negative, or 0, you must substitute back. So we shall remember we are having 2 points. We have 2 points. So let's start with the first point, 0, 0. Under 0, 0, our x value is 0. So let's start with this. Now 6. Now we have the squared y over the x squared is equal to 6 minus 6 into what, guys? Instead of having x again, now we substitute it with the x, which is 0. What will be our answer? 0. So that means 0, 0 is a point of inflection. So you just write there inflection. You shall organize them later after, when you are coming to now summarizing your answers. Now, d squared y over the x squared equals to 6 minus 6x. We are now using the second point we had got, or we had obtained, which is 2, 4. And in the second point, our x coordinate, or our x value is 2. D squared y over the x squared equals to 6 minus 6 into what? X is 2. 6, when we shall have 6 minus what? 12, which is negative 6. And remember, negative refers to a maximum. So this one is maximum. So now when you're summarizing to your final answer, you now say therefore. Just therefore 0, 0, 0, is an inflection. Do not worry about my handwriting as long as you are understanding whatever I'm saying. 0, 0 is an inflection point, or is a point of inflection. 2, 4 is a maximum point, or point of maxima. Very much easy, very much interesting. Imagine doing just this. You have 10 marks. 10 marks with you. Great. That is the end of the number 3 part, which is stationary point. So whatever you want to discuss in number 4, I want us to look at part number 4, that is curve sketching. Remember, the functions can be termed as curve. There are some point we read a question, and instead of the examiner telling you a function, he or she is talking of a curve. So that's why I'm telling you that a curve can also be termed as a function. So what is curve sketching? This is the drawing of a curve using the points of stationary obtained only after determining whether they are minimum, maximum, or inflection. In short, that is only after determining their nature. It will be very difficult for an examiner to set a question under direct or express stationary point, whereby after having your dy over dx, you are only getting a natural number. And remember, in those type of questions, they only have 1 point. And it is very difficult to determine the curve, how it has appeared. But again, it is easy when you sit down with your book and learn, because there are some curves that appears this way. But remember those ones with only 1 point. The curves with only 1 point will only appear in the y-axis, either in the positive part or the negative part. Nothing is difficult. You only have to learn. You have to enjoy. You have to laugh. Yeah, that is it. Okay, having that, let us look at curve sketching. Let's start with the first example. Where we had we talked of the direct or express. I only want the point. Now under direct, we had the points to be -1, 2. And determining its nature, the nature was that it was a minimum. Point. The nature of -1, 2 was a minimum point. Now, drawing a sketch of this, you will have your Cartesian plane, whereby we have 1, 2, 3, 4, 5. 1, 2, 3, 4. Remember, it is just a sketch. Just a sketch. 1, 2, 3, 4. 1, 2, 3, 4. But you can use a ruler to make your work look neat. And also, you have to train on how to draw the accurate the curve, the accurate curve, because your curve can appear to be dancing along the way. Though it is the right one, but it will have some meanders. It will have some meanders. It is going up. Something which is bad can also lead to you losing some marks. So you have to practice. You have to train on how to draw a smooth curve. Though mine is not that much smooth. But those are something you only have to sit down and practice and practice. Now remember, our Cartesian plane must always have an arrow. That is something you must have in your mind. So we have 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4. Minus 1, minus 2, minus 3, minus 4. Then we have 1, 2, 3, 4. Very much good, very much good. Now, let us sketch. Minus 1, 2 is the minimum. Something that is minimum is something that appears at downer part. Downer part. So minus 1, okay. It is, okay. Remove that idea of appearing at downer part. It is not a must, but being provided with whatever you've calculated will lead you to the accurate answer the way it is required. So having minus 1, 2, minus 1, it is at this point. Then our y, it is at this point. So that means this curve appears to be something like this. Yeah, something like that. Okay? Yeah. And that is why I told you, you have to practice. You have to practice on how to draw. But I am using a computer. You will forgive me for that. Yeah, this one is at least better. You have to practice on how to draw a curve. The one that appears very much smooth. So this is what is required for that point. This is curve sketching. So let's check at the stationary ones. The stationary. So under stationary, we had our points. We had our points as 0, 0, 0, 0, and what? And 2, 4, and 2, 4. Remember, this one was point of inflection, and this one was maximum. So come and draw your sketch. So we have 1, 2, 3, 4. 1, 2, 3, 4. By the way, when drawing this thing, you must use a ruler. All the distance in between should be proportional. If you decide to use 1 centimeter after the other, then let it be constant to the end. Let it be from this point 1, from this point 1, 1. I mean, the spaces after each and every number should be 1 centimeter, and it should remain constant for the whole Cartesian plane. Or even if it is 2 centimeter, should remain constant the same way. And I should be neat. So we have 1, 2, 3. 1, 2, 3. So here we have 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. Yeah, you have 1, 2, 3, maybe 4. Here 1, here minus 1, minus 2, minus 3, minus 4. Then you come and sketch. 0, 0 is obviously at this point. You can either use a dot or an X. But I prefer X. So, and 2, 4, 2, 4, 2, 4, 2, 4, it is at this point. So when drawing, your curve will look like this. Your curve will come this way. Sorry. Let me try to be more accurate. Yeah, your curve should look like something like this, and it should look this way. So point of this one is 0, 0 point of inflection, and this one is point of maxima. So I would recommend you write 2, 4 maximum point, 0, 0 inflection point, and you have a tick. If you still can't understand how to curve sketch, feel free to drop a comment in the section and I will teach you for free. I promise. I'll teach you for free. You only have to get a laptop, maybe any computer, and WhatsApp. Everything leave for me. The rest leave for me. So after that part, guys, we've come to the end of our lesson, and I thank you much for always following, and I wish you all the best in understanding anything you're learning or anything you are trying out to know. So when we meet next, we shall look at number 5. Remember, I told you calculus is the longest topic in Form 4, and you must be very attentive for you to understand. So at number 5, and that is why even me, I can't discuss everything in calculus at all. And that is why I've simplified my work for any person to understand. So next time when we meet, we shall look at what is called maxima. And minima. Remember, it is very much different, totally much different from maximum and minimum. I recall very well telling you that some people do call maximum as maxima, or some people do call minimum as minima. But now when it comes to this category number 5, it is something different from the maximum or the minimum. And both of the maxima and minima can be called mensuration. Mensuration. Guys, I thank you so much for always following. I thank you so much for always watching. What I urge you is to subscribe and don't forget to invite your friends also who are still learning. I thank you a lot. I have not taken it for granted to share knowledge with you. Thank you very much and have a good day. Thank you.